Alrighty, guys. You know, we're going to go ahead and move on to evidence 2 that evolution has indeed occurred, and that's going to be the fossil record. Now, I want you to think about if you've ever gone for a hike and you've just been walking around and you look and you see like the different layers of rocks that have built up over time. And of course, that occurs due to weathering or sedimentation building up as a result of the breakdown of various minerals, etc. But when you're walking, have you ever wondered, like, well, yeah, that rock layer on the bottom must be older. And the same thing goes for the fossils. And so people who actually study this are called paleontologists. So to define paleontology, we are just going to simply say that this is someone who studies fossils or the study of fossils. Okay, and then what I was talking about with that, here, I'll leave that there. But paleontology, the study of fossils, what I was talking about with that strata, or the layering of the rocks, and rocks being older, closer to the bottom, is strata. So this is the layers of rocks. And of course, as it makes sense, older rocks are going to be closer to the bottom. Now, what we've found is that the same holds true for our fossil record. So if we're looking here at our fossil record, here's our, far, far back in the past. And we can go from looking at the first skeletal elements, right? We can find this in the fossil record, the first soft-bodied metazoans. You're going to have things like trilobites coming up in this first area. And then what you see are these really simple organisms, right? But then as we move up in the fossil record, right, you get these more complex organisms. And as we go, everything gets more complex. But what's also really cool is that notice these amphibians, they came before land animals, but they also came before plants. And that makes a little bit of sense, right? Because these these amphibians are going to be in the water where the excess amounts of oxygen are going to not be necessary. And let me back up there. We did get first vascular land plants, right, in the Silurian, but that vascularization of those land plants still wasn't producing massive amounts of oxygen as you might see in the things like trees and ferns. So it makes sense that we have these amphibians coming before we have these massive land plants. Well, then, once we get these land plants, notice what happens. Our animals, our amphibians, are able to evolve into becoming land animals. And so, and as these things go on, we see these more complex organisms coming into play, things like mammals, which are more complex than reptiles and dinosaurs, primarily because of their reproduction patterns. So it also makes sense, like, look, we really don't start seeing these flowering plants until we have an organism that can help to pollinate these plants, like the first birds. So these things just fell into a line. This is what we would expect to see. And so that's what our first piece of evidence here, provided by fossils, is that the sequence that these fossils come into is what we would expect to see, right? For example, it went bacteria. We have the first fossil record of bacteria, and it falls in line on that strata, deep down. That was cyanobacteria, to be specific. From bacteria, we got water-loving algae, right? And then we moved from algae to those invertebrates. From invertebrates, we went to bony fish, to amphibians. From amphibians, I'm going to come down over here. Right, so I'm starting a new line there. From amphibians, we go reptiles, and then ultimately to those mammals. So that kind of starts to make sense. But not only that, but it also makes sense that as organisms evolved, right, we started to see that they fall in line with their ecological groups. So the strata also matches what we would expect to see with ecological groupings. What I mean is what I was talking about earlier, how we've got the land animals depend on those land plants. So clearly we saw land plants evolve before we saw land animals. And so it just makes sense that those appear first in the fossil record. So then we have our third piece provided by fossils here. These fossils show an accumulation and this ultimately shows this divergence. It's going to be a big word coming up. Divergence. I misspelled it. Oops. So the divergence from a common ancestor. And this is where we're going to start seeing things like the family trees coming in. So that's the fossil record, right? That's evidence number 2 that evolution is occurring over time. And there's a lot of evidence in the fossil record, but don't forget that there's also missing evidence here, right? We have a lot of missing links here in between these spots. We still, you know, as the search continues, we don't know, like, the missing link. We haven't found those missing links between primates and the humans, right? And we've gotten pretty close, but we still are not quite there yet.